recording.
Do you have the attendance sign in today?
I do, yes. So if you want to go ahead and let me throw that back up here.
Your phone charged?
Yes, it's plugged in this time.
There you go.
So it's plugged in. I've got attendance, and it's the first day back after spring break. So I'm telling you.
Well rested.
Yeah, rested. We were on a cruise with my kids. It's one of those things that you get a lot of rest, but you also are exhausted.
Yeah.
You know. Anyway, everybody good here signing in? Cool. All right. So let's talk about two of the projects, the countdown. So this is, I call mine countdown keys as the completed version. So this was already done for you, right? Where you asked for a number, and then you had to check to see if the number. So let's back up. Last unit we talked a lot about if statements and loops, right? So conditionals and Boolean conditions. So you had to check to see if the number was greater than or equal to 1. And I put, but also, I didn't put the word and, because that would give it away. So I said, but also less than or equal to 10. So that's an and we use a double ampersand. So I said, if I is greater than, or if num is greater than or equal to 1, and it's less than or equal to 10. So if it's in the correct range, then what do? Well, I want to loop. Oh, but I want to do backwards. So I started at num, and then I did, while I is greater than or equal to 0, I minus minus. And you could have just said, you could have had a while loop while num is greater than 0 and done num minus minus as well too. I just made a different variable, but you could have done it either way. Lots of different ways. I used a for loop, you could have used a while loop. And then I just printed out and then printed the word blast off. Otherwise, we printed the quote from 2001. I'm sorry, Dave, I'm afraid I can't do that. So when I run this, then it's over on this screen here. The number between 1 and 10, if I put in 22, then it says, I'm sorry, Dave, I'm afraid I can't do that. But if I run it again, and I put in a number, and we put in, say, 7, then it prints out 7654321 blast off. I guess they really don't say 0 blast off. But, and if you haven't done that one yet, if you're a little behind, check that one out. It's a good one to do. So a little bit of a hint, you can see how we did the loops and things like that. And the goal is, this is not, I sent out a message earlier about, hey, making sure you get the assignments in so you get the PD points and get the full stipend as well too. It's not like, these are not assessments. This is just, hey, this is how we're showing that you're working on this outside of this session. I'm happy to help you through it. And the more that you just do it and practice it, the better you're going to be prepared for the exam. Even with questions and helping through it, you don't have to be a master at this in order to do well on the certification exam. I almost said AP exam. I'm talking AP exams, IB exams. It's that time of year. Everyone's been testing. So, good on this one? Yes. The second one we did was the Pig Latin from here, and it's somewhere. Oh no, sorry. Magic 8 Ball. Pig Latin was the other one.
Yeah.
Magic 8 Ball. I had it pulled up. So here is a solution. So we already talked about, I gave this to you in one of the slides of how to do math random numbers. I don't even spend too much time. That wasn't the point of this exercise, is to get that exact magic number range, right? But so there it is. And I had cascading, or I had just a bunch of ifs. Could these have been else ifs? Yes. And would it have made a difference? No, because these weren't ranges. So remember, like in the earthquake one, we had greater than or less than or grade ranges. So this was just, it had to be one of these 8 numbers. So I could have had else if, or I could have just had a bunch of ifs. Either way, I got lazy. I just put a bunch of ifs. And then, yeah, these are our results from here. So questions on this. So then if you run it, then you should get the little, green boxes, you go from there. Cool, good. All right. So today we have 2 sections. Well, first of all, any other questions on the previous stuff at all before we move on that we want to? So we've gone through a lot. The first unit, which was kind of more jam-packed than it needed to be, but it was all about variables, right? And then we did if statements and loops. Today, we're going to talk about classes that we use to create objects. But before we get into the Java part of it, we're going to do our non-Java section first. and that is the first set of slides. And this is I will tell you my least favorite part. This is just networks. And it's relatively short, but I'll be very upfront with you. A lot of it is just memorization, vocabulary. Like if you really wanted to look at this, hardcore flashcards would be good. There's not a lot of problem solving, figuring things out. There's just a lot of technical terms and describing how networks are used. I have some sample questions at the end, so once we go through the material, you'll see the types of questions that are asked about networks. But really, there's not much to it other than just memorizing the terms, or at least the context in which those terms exist in. So that's kind of where we are for this. So I apologize if it's a little on the dry side. So let's talk about networks. So in your study.com, the chapter 6 is of the FTCE unit in study.com. That's all about the basics of networking systems. So I got a lot of this information from. I did pull some from other sources that I thought were just better explaining it, and some good pictures as well, but some of them are right from there. So what are networks? Networks are the thing. Computers are great, but without networks, they'll allow them to communicate with each other, to allow us to communicate with each other. They're really just kind of fun little toys in our hands. They're address books or flashlights or game consoles. When they connect to networks, they become communication devices. Internet devices, wealth of information that we have the entire world at our fingertips, right? Because they're interconnected with each other. So networks, huge important part about computer science. Chapter 6 goes into a lot of that. So we'll start with talking about what we call the network architecture. Think about architecture, about how something's built. It talks about maybe a design of how things are built. And this is kind of our eagle-eye view looking at something, just the basic way computers can connect to each other. There's what we call a peer-to-peer network, where, and we'll see some different examples of this, where all the tasks are allocated amongst all the computers kind of evenly. So the way things, you might not have one supercomputer, it's different computers are tasked with different ideas or different jobs within a network. A lot of times, say back in older days before printers were network printers, a lot of times you had to hook a printer up to someone's computer, and then everyone had to send their jobs through that person's computer to print it out, and that slowed that person's computer down all the time. And when I worked in industry, we always had that one computer that if we needed another desk for someone to sit at, they got that desk where, sorry, your computer's gonna slow down because it's hooked up to the printer. But peer-to-peer is where it's all distributed. Client-server is where you have the idea where there's a couple main computers, and most of the software runs on that. If you think of like a Chromebook and a cloud service is kind of the modern version of a client-server, where the client is the Chromebook and everything's running, and they're dependent on this big computer somewhere where Google Docs is running, or whatever software they're executing, and really is not a lot executing on the Chromebook itself. And then in a mainframe system is what you would see more in like maybe a military situation or a large business where you have one or two main computers, and then people have terminals hooked up to that. Or if you ever see like a TV show, someone breaks in and they hook up a little mini screen and start typing into their big computer there. So that's the big mainframe system, and everything is run on there. There's just different people accessing it at the same time. So those are the kind of different high-level architectures. Then we can talk about the different size of networks, right? Meaning how many computers are actually doing all of this work together. All of these have really cool little acronyms like PAN, LAN, WAN, MAN, and things like that. None of the other ones don't. But so a personal area network would be something that you might have in a single, not even your network at home, but I'm even like a room, like where your computer and you have a game control console hooked up, you have something else hooked up with Bluetooth, and it's all right there, and then maybe you're hooked up to the internet. But there's a lot of things connected just within, like it says a small office or residence, not like what most of us might have at home. That would be more of like a local area network, where we have like a single site, an office building, maybe your house, you have like your routers connected to the internet, and you have a wireless router where everyone's logged into, and then maybe you have a repeater because your signal's weak in the other half of the house that you are always in, and the internet's on the other side. But that'd be a local network. A metropolitan area network, which I gotta be honest, I'd never even heard of that until I started putting these together again. A MAN would be like a college campus or an entire city, a metropolitan area. Then you have your wide area network, or your WAN. That would be something like the internet, something worldwide. Most WANs are made up of smaller networks, right? So all your home system hooks up through cable or fiber optics to the internet, and everyone's system together makes that a wide area network. And wireless, any of these can be wireless, right? Or wired. Most are wireless nowadays, right? Some of you might have your computer, you plug it in at home over the network. You might have an older computer, or the network card is not that great, but so many, like obviously everyone here with their laptop out is all wireless right now, going through the network device up top there. So any of these could be wireless or wired, right? Depending on how they work. Here in this classroom, these are all hooked up. These are all wired. So this would be a good example of a LAN. Well, you might call it a MAN, a metropolitan area. I would still call this a local area network. And these are all hooked up. And we used to have a server in our building where that was where, do you remember having like H drives and U drives?
Yes.
So we used to have that. That was used to be in each school. Then they moved them all to the county. And then now it's just all OneDrives, right? I don't even know if the county stores anything anymore for us like that. So, and you Seminole Virtual School people probably have a whole other set of network type of things as well. All right, some other, again, this is just definitions. I'll go through these. Things that make up the pieces of your network. We have repeaters. I mentioned that. That's kind of to help boost the signal. A lot of people have them in their houses to boost the signal somewhere else or repeats it. A hub is a networking device to connect lots of different things to the network using cables. Right there on that bookshelf, it's turned the other way, but you can see there's a black box with a lot of cables plugged into it there. That would be a hub. Bridges divide the network into different segments and then allow traffic to go across them, so it kind of connects other networks together, and it's a way of allowing, of directing traffic across the network. It's kind of like traffic or network management. Routers is if you have a home network you're familiar with. Oh, I've got a wireless router, or I've got something that takes in all the signals that then is connected to my cable modem or my internet modem that connects me to the outside world. But the routers connects different networks together, so it allows you to connect you with whatever service you have right through there as well too. A gateway is an interface to help two different networks and have different protocols. I'm not going to talk too much about protocols, but think of them as languages or standards or ways to connect those together. And if you connect those two different networks, the gateway can kind of translate that. Yeah.
Is it protocols like WPA?
Yes, all the way the network communicates within itself. And of course, if you have an advanced network, you still want to communicate with someone using older technology and use gateways for that.
Okay.
The modem is a device, it says to modulate and demodulate data signals. Basically, it takes, it does more than just the analog and decodes it. It really is it's that additional bridge lot to take the signal through your cable and then transmit it to wireless, right, or to your wireless router. The network interface card is a piece of hardware that you all have in these laptops that allow you to connect to a wired port or to a wireless modem that's floating in this room. So you have that in your computer that allows you to connect. That's just a lot of terms I just threw at you, but that's hopefully some of them are familiar. Some of them, oh, I see what that is now. I've heard of it, didn't know what that was. There we go. So we talked about the high-level idea of a peer-to-peer architecture. We talked about how many computers are on there, and we talked about some important things within components of the network. So now there's network designs. Now how are we going to connect all these computers together? We know we have two, and they're peer-to-peer. Or we know we have sort of a client server, and there's going to be 500 computers going through here. So now, how are we going to connect them all together? What's going to be the strategy, the design? That's what these next few slides are all about. Different, what we call topologies, the design of the system itself. So the first one is called point-to-point. So I've got two computers, I put in a wire cable between them, and they can now talk to each other. That's really helpful if you like buy a new computer and you want to take everything off your old computer and put it on your new computer. You can make a drive accessible on the one, and then the other one you hook into it and copy everything off of it, as opposed to taking your USB drive and plugging everything back and forth and back and forth. Or you could upload it all to the cloud and then download it all from the cloud as well too. That's another strategy.
Does it have to be another computer? Could it be a phone or
a phone is a computer. Yes, so if you take your phone and you plug it into, remember iTunes, like on your computer, and you would then download all your music from your computer to your phone and vice versa. That is exactly a point-to-point.
What about an external hard drive?
Only because the external hard drive is not a computer, we would call that a peripheral device. Remember we talked about input and output devices? I would classify the hard drive as an input-output device because you're just transferring information, but it's not doing any calculations or anything itself. Good call though, about, putting those together. Two computers, two desktop PCs, or a phone, and because you're transferring pictures off of it. The other one's going, I'm gonna, I always tell students here, they want to charge their phones on the computers. I'm like, I would never plug my phone into an unknown computer because you don't know what's on that computer that could then damage your phone or delete pictures or whatever. So we have charging stations. Just don't plug your phone into unknown computers. They can back and forth with each other. This is very fast. Because a wired connection is always quicker than wireless, right? Disadvantage, small areas, right? You can't like plug in a computer that's across the, and we'll talk about advantages and disadvantages of all these designs. A bus uses kind of like multiple computers, but still using this cable idea about cables that can connect lots of different computers directly to each other. It's not like you have forked wires, so there could be something right here to help manage how those are plugged in. We'll talk about like different, like a router or a hub or things like that as well too. But the idea is that we can connect lots of computers, and if one of them had like a printer or a peripheral device, then another computer should be able to get to it. It's very small in cost. It's all wires, so it's a low cost. Yeah.
How is this different from like, because I know USB stands for like Universal Serial Bus. How is that?
Different. So there's also like the bus on your like on the motherboard itself too to transfer. So a lot of times they use bus in terms of just anything that transfers data. So that'll be a common term, like get on the bus and moving it from one place to another. Why they call that? I don't know. The small, because you're transferring data from around, I guess. But just and this is all on the same wires, so they just call this a bus because it's just all wired. There's no other external, and they're just all connected to the same wires. Now, disadvantages: if that cable is bad, the whole network goes down, right? So that's a disadvantage. Also, again, it's a small area, right? You can't do it over an entire building. A star topology, and some of these you'll see are actually combinations of different ones. A star is where you have, I can't otherwise wires connected but I have like one central hub, and I just plug everything into that. And it doesn't look like, it doesn't be 5-pointed, right? But that's kind of the idea. This is very popular. This is kind of what, before wireless, a lot of people have in their house, right? They plug different computers into their hub or into their router that acted as a hub. Startup costs are low, but again, if the hub breaks, everything's gone, right? So you have that one main link in an entire network that if that fails,
destroyed
again. Yeah. So like I said, if the hub fails, the entire network goes down. Also, it's more cable than the bus topology because it reaches out to every single computer as opposed to connecting like your computers down like a chain, like a line. A ring. So a ring is just where you like that. You kind of like a bus, but instead of you take a bus, and if you were to connect the ends, then you have a ring. The idea is that in a circular fashion, and data generally, the arrows on this picture are weird. I didn't notice how they use it, but data generally travels in one direction. This was
We can't see the mouse.
arrow, and then I don't know where these two arrows came from. They're the wrong way. So
like
these
back
two,
and forth to each device.
yeah, back and forth to
Let's
each
hook
device
to
is
the
fine,
right.
but these should all be like in counterclockwise or
Oh, I see what
clockwise.
you're saying.
So it's connected and data travels in one direction. So that is it's very easy to manage that type of network. It's small. It's easy to pinpoint if there's an error somewhere because the data stops at that computer. It's a little more cumbersome and it's a little more tougher for the computer to manage because it has to put the data in that direction. It doesn't just go out there and go wherever. If one computer fails, the network goes down again. Now this, the mesh, this is where every computer is connected to everything else as much as possible. This is great because what happens if this computer fails? No one cares
Then that
because
was
all the
alright.
other ones are connected to each other. What about if two of them fail? No big deal. Disadvantage? A lot more cables or a lot more
Right.
technology to connect everyone to everyone else. You're not just going in a single line, you're not just managing that. That's a lot of different paths. Depends on how fail-safe do you need this. The internet itself is kind of like this idea of it's a mesh. As it's sending packets of information, you're sending something here in Florida over to like Washington, and it's like there's a website in Washington, you're accessing and you're getting data from there, and it's traveling somewhere. It could be traveling overseas to get to Washington, but let's say it's going through the middle of the United States, and anybody here from Nebraska? Great, so we lose Nebraska, something happens, and what happens, then the data just reroutes, right? Goes around somewhere else, and
Yeah.
that's okay. So, something like that happened. Again, very expensive, but this is where we get all of our networks. A tree topology. You know it's called a tree because it looks like a tree. Now you'll notice, wait a minute, this is like a bus, but then it's got stars and hubs on the bus. So it connects multiple star networks together. And we call it a tree. Great for expanding because now you have this backbone cable. This could be something that runs through the entire building. It said like this would be great for an office building. Maybe you have a major like a fiber optic cable coming to the building and it goes up like an elevator shaft. And then everybody connects off of that, So that would be a good example of like a tree technology here. Each hub is like the root of a tree of devices. And again, you can expand it because you can just keep adding on to it as well too. Hybrid is where you just, any combination of whatever, right? Maybe that building example here, you're talking about a bus running vertically through the building, but one floor is going to work just to have a star technology, but one might have like a ring on their floor, and then maybe maybe there's just a row of computers in the basement or whatever it is. So again, some sort of hybrid topology. The design of the networks again are just based on however you decide to hook those up.
Mm-hmm.
We'll talk about like what you might see in those types of questions there. All right, so. This gets really into the weeds a little bit about network communication and protocols. Remember, talking about protocol being the way the network, the language that it uses and the standards that it does to transmit data. This is something called the OSI model. Basically, it is the different steps that your data goes through as you're sending data out and receiving it, right? So we have the application, which is the interface for the user, what you see, your data putting in there. And then presentation, it converts it into a format that we're about to send it out. The session layer preserves this communication between the different elements of your computer. Transport is a way of saying, okay, we're sending out these packets now, and these packets are what can then be universally sent, transmitted, and then received and put back together. The network layer says where are these different packets going, and then the data link controls where they go on the network as well. And then the physical layer is where you send the bits exactly through the different channels, whether it's wireless or whether it's through the network itself. And so these are all the different levels of control. I put this in here because there was a question about the OSI model, which I'll show you in there as well too. How deep do you need to go into this? I wouldn't bother too much. But just knowing that the OSI model has different layers from the application where the user interface is all the way down to how that data is transmitted at the physical level. And it was a lot of information that I'm sure 60% of it at least went, hey, I gotta go back and read this some other time. So kind of keep that in mind as we're going through. So let me show you some sample questions that we have and what you might see here. It says, which of the following devices, these are off the sample FTCE website as well, and I think I have some study.com questions in here too. Whoops, I didn't mean to do that. All right, so which of the following devices would be appropriate for connecting a local area network using one protocol to the internet using a different protocol, right? Because your local area network and then connected to the internet. What would you think about? What would you use at your house to connect? Yeah, your local area network to you would use a router. I would hope they would not put modem up there because the modem. Cable companies will provide a cable modem / router all in one device. So yeah, or you might have it separate as well. So it depends. I'm glad they didn't put modem as an answer because that gets into the nuances a little bit more than we need to.
And gateway, I mean, I know it's not an answer choice, so
Yeah.
but like, it sounds like.
That's usually what help to flow traffic within a network itself. Like we're going to connect, let me pull up here where it was.
It says.
Yeah, between two different networks with different protocols. So it's not
gateways
necessarily.
Make it possible to connect networks using different protocols. And this says.
And it does say router and
connect
gateway are
one
used
protocol
interchangeably.
with a different protocol.
Yeah, and then notice it says on gateway, the terms router and gateway are often used interchangeably. I've always thought of a gateway as deliberately between two specific networks, as opposed to a router which connects me to the outside world network. That's how I always thought it in my head, but they say how they're using the router and gateway. I guess you could technically use it interchangeably. I would never call a gateway a router or a router. I mean, I guess they could be technically interchangeable. So glad they didn't have gateway up there as one of the answers also. That would have been.
It's a square and a rectangle situation.
That would have been
Yeah.
the one that I picked.
There you go.
When
Gateway.
connecting, sometimes the gateway IP.
Yeah, exactly. So yeah, true. That as you're going to the internet there, yeah, definitely. All right, which of the following open systems interconnection model, the OSI model, is wireless network technology implemented? That's why I included the whole, what is the OSI model? So if I go back, where do we talk about wireless network technology in the OSI model?
Physical.
In the physical level, in the physical layer, right? So the answer for that would be D, physical. Now they do mention all four of those are different layers of the OSI. Take your best shot. You know, it's one of those. Yeah. All right, here's some. I pulled these. These are from actually study.com. So those are the only the network questions on the FTCE website. But I thought these were also very similar to what you could see also as well. What is one characteristic of a mesh network topology as compared to a bus, star, or ring? So if I said I've got mesh and I've got maybe bus, star, or ring over here, what would you say is a characteristic of the mesh that's not a characteristic of bus, star, or ring?
Expensive.
Expensive to configure and troubleshoot because something that you don't know where. There's 50 million wires in there, right? And it is more expensive, definitely. Which of these describes a WAN? Not a man, not a LAN, not a PAN, but a WAN.
Very large area.
Yeah, large areas such as the country or the world. There you go. All right. And that's our part one.
Yay.
Questions on these? Sorry, that was a little bit of just, here's a bunch of information I'm going to throw at you, but that's kind of the idea for networks. Hopefully you don't get too many questions. But if you get familiar with it, you read through that, and you get a few questions on there, you can kind of at least point you in the right direction through process of elimination, things like that, okay? All right. I'm going to